Assalamualaikum dan hi again. Today I would like to talk about the application of stack regarding arithmetic expression. In previous video already explaining the concept of stack. Now I will focus on how to use stack in arithmetic expression. Okay, in this video I will explain how to utilize stack in order to firstly to convert infix expression into postfix expression. Secondly, to convert infix expression into prefix expression, and the one is to evaluate postfix expression. Okay, there are three operations that we highlighted in this video. Okay, stay tuned, all of you. Okay, before we proceed to the operation, let's look what is the arithmetic. Let's look what is the arithmetic expression. Okay, the arithmetic expression is a syntactically correct combination of numbers, operators, parentheses, and variables. Okay, the two main symbols are operators and operators, and the parentheses is usually is optional. If you want to, sometimes we need to use, sometimes we do not need to use. Okay, the compulsory component to create arithmetic expression are operands and operators. Okay, what's the operand? Operand is a variables or numerical values. Okay, in our expression. And secondly, the operators. Operators is a arithmetic symbol, such as addition operation symbols such as plus, minus, or subtraction, division, multiplication, modulus, exponential, and many more. Okay, there are three types of arithmetic expression. Firstly, infix. Infix expression is very common for us. We already use in our daily life for the arithmetic. Is very. I think all of us use this kind of expression for mathematical operation. Secondly, the postfix expression, and thirdly, prefix. Okay, let's look the details of these three expression. Okay, firstly, infix. Infix expression is infix expression. Infix expression is a format where operators is specified in between two operands. It means the operator will place in between of two operands. Okay, for example, a plus b. Okay, operator plus is placed between the a and b. Okay, another example, a plus b multiply c. Okay, so it will always be operand left and right of the operators. Okay, another example, a plus b put in parentheses multiply c. Okay, secondly, the postfix expression, a format where operator is specified after operands. Okay, it means the operator will place after the operand. For example, a b plus, ABC multiply plus, AB plus C multiply. Okay, this operation, this expression is equivalent with the left side of the infix. For example, a plus b equivalent with AB plus, a plus b times c equivalent with AB times plus, a plus b parenthesis multiply c equivalent with ab plus c multiply. Okay, so means in the postfix notation, the operator will place at the right after the operand. Okay, So in order to convert infix to Postfix, there are some rules we need to follow, and I will explain later. Okay, another one is a prefix notation or prefix expression, a format where operator is specified before operands. As we can see in the example, plus AB, plus is placed in front of the A and B, plus A times BC, multiply plus ABC. Okay, so we can differentiate. Obviously, we differentiate between these three kinds of operation, arithmetic expression. Okay, infix, postfix, and prefix. Okay, as I mentioned earlier, infix we always use in our everyday, in our life. Okay, but for postfix and prefix is actually it's used in computer processing, where the computer needs to simplify the expression first into a postfix or prefix. For example, as we can see here in the infix, it includes parentheses. Okay, and another one in infix expression is needs to determine the precedence rule. In case we have several same level of operators, for example, plus and subtraction, addition and subtraction operator are in same level of precedence rule, then we need to determine which one should be executed first, then it's imposed with the precedence rule. Means while postfix and prefix avoid from to involve the parentheses and precedence rule. Okay, that's why in the computer processing we will prefer to use postfix and prefix notation rather than an infix notation. Okay, now I will explain the rules for converting infix to postfix notation. Okay, actually this rule is will be applicable for operators only. Meanwhile, for the operand, it's not use these rules. Okay, so the operand is just straight away put into the postfix notation. Not needs to determine using these rules. Okay, so this rule only applicable for operators. Okay, for example, A plus B. A is operand, then A is not needs to use these rules. It's just straight away put into the postfix notation. But for the plus, for example, A plus B, plus is will determine using these rules. Okay, another one is B. B is operand as well. It will just straight away put into the postfix notation. Okay, let's do the rules. Okay, first, print operand as they arrive. If we found it is the first letter, the first symbol is operand, so we just print or just put the operand into the postfix notation. Okay, actually, let me explain first the scenario how to convert. We have the expression, the infix expression, and the expression we put into one string variables. Okay, then we need to get one by one the symbol in the expression. Okay, for example, we get the first symbol. Example is an operand, then it will straight away print as a postfix notation. And the second symbol is the operator. If the operator, it will impose with these rules. It needs to find the suitable rules for that operators. Okay. Okay, let's continue. Okay, firstly, print operand as they arrive means just put the operand. If we found operand, then just get the operand and put into the postfix notation. Secondly, if we found it as operators, okay, we need to identify the operators. Okay, second rule, if stack is empty or contain a left parenthesis on top, push the incoming operators onto the stack. Okay. Okay. The second rule is in case the stack is empty or contain the left parenthesis. Okay. If the case, there are two cases. Okay. Either no empty or contain left parenthesis. So the incoming operator will push or insert into the stack. Okay. Third rule. If incoming symbol is a left parenthesis, push onto the stack. Okay. Quite similar to second rules. Okay, if the incoming symbol is left parenthesis, then push onto the stack. Push the left parenthesis inside the stack. Okay, next, if incoming symbol is a right parenthesis, pop the stack. Okay, print the operators until left parenthesis is found. So if the incoming symbol is right, then pop all the symbol in the stack until found the left parenthesis. Okay, so the rules number 2, 3, and 4 is actually dealing with the parenthesis. Okay, in case we deal with the parenthesis, we need to consider rules number 2, 3, and 4. Okay, next, rules number 5. Okay, this is the most important rules. Okay, if incoming symbol has higher precedence than the top of the stack, the incoming symbol is higher precedence than the top of stack. Okay, as we know, as we learned before, the new item will be placed on the top of the stack. So we will compare the incoming symbol with the item operator on top of the stack. In case the incoming symbol is higher precedence, then we need to use this fifth rules. Push it on the stack. Means insert the incoming operators into the stack. If it has higher precedence, the incoming higher, then push into the stack. Meanwhile, for the sixth rules, if incoming symbol has lower precedence, lower means, for example, the incoming is plus and the top of stack is multiply, so it's lower precedence. Then what we need to do, pop the multiply. Means multiply is the top is placed on top of stack. Then we need to pop the multiply out and print on the top. Then test the incoming operator against the new top of the stack. Then the new incoming person needs to test with the next top of the stack. It will found that the incoming the new operator higher precedence that you can push. Okay. Okay, this step will be repeat and repeat if all the incoming operators is lower than the operators on the top. Then the rules needs to pop out the current top of the stack. Okay, this is the 6 rules. And as next, the 7th rule, if the number of operators has equal precedence, same precedence, same level of precedence, for example, plus and exception. Both are the same level. Okay, what to do? Actually, it's quite similar to 6 rules. Okay. Okay, the difference is use associativity rules. Associativity means we need to consider left to right or right to left. I mean, normally we consider left to right lah. Okay. If the infix notation, the operator in the stack is left, arrive earlier, then you need to pop the operators in the stack. Okay, actually it is quite similar to the 6. It means we need to pop out the top operator on top of the stack. Then okay, this will repeat again and again until we found the incoming operator is higher precedence. Then we need to go back to 5th rules. Okay. This might be confusing if I just explaining like this. Then I think we will show you, okay, the example how to execute this formation. Okay. Lastly, at the end of the operation, pop all the operators of the stack. After we go through one by one as operator symbol in the expression at the end, but in the stack it still has operators. Then what we need to do is we just pop all the operators in the stack until the stack is empty. That's it. This is the operator. Okay, so let's do some exercise using these rules. Okay, this round I will show the example of conversion from Infix to Postfix. And this conversion will be used the rules that I have been mentioned just now. Okay, we will walk through several example here. Okay, let's do this. Okay, we start with the first expression, a minus b. Okay, let's look how to solve the expression. Okay, we take the expression a minus b consists of 2 operand and 1 operators. Okay, then firstly, as I mentioned earlier, how we execute convert. We convert, take one by one, symbol by symbol. Firstly, operand. First symbol is a. A is a operand. Okay, so our algorithm should identify the symbol first. Is it operand or operators? Okay, firstly a. Okay, we take a. Okay, token a. Then the action after it, our algorithm determine it is an operand. Then print the a. Print the a means straight away do not need to process or determine to take any action on the a, the operand. Then just straight away convert to postfix expression. Then we got a as a postfix. So this rule is actually based on our first rule in rule number 1. Okay, second, next operand is operator minus. Get the next symbol is minus or subtraction symbol. Then the action. Okay, the action actually our stack is still empty. So what we have to do is we can use second rules. Okay, the second rule stated that if stack is empty or contains a left parenthesis on top, push the incoming operators onto the stack. So now there is no any item in the stack, then we just push into the stack. Okay, the minus, the symbol minus of subtraction, push insert into the stack. Okay, so item is stack, there is one item minus. Okay, so postfix expression still a. Okay, we did not hold the subtraction in the stack. Then the postfix expression still a. Okay, next symbol is b. Take b. Then b also is an operand. Then just straight away print the b right after a. Okay, a b. So okay, what the stack item is stack still one item minus is there. Then we finish. Take all the item or symbol in the expression. Then we are now we are using the rules number 8. Mention that at the end of the expression, pop and print all operators of stack. Okay, right after we have done taking out all the symbols, then we need to proceed with the rule number 8, which means we need to pop all the items in the stack until empty. Now we have one symbol minus. So now the postfix is AB, then finally the final postfix expression is AB minus. Okay, easy, right? Okay, let's do the second expression, A plus B minus C. Okay, this expression consists of 3 operand and 2 operators. Okay, as usual, we take one by one the symbol in the expression. Okay, firstly take A. A is identified as operand, then just print the A using the rules number 1. Okay, so postfix expression is A. Okay, next, the next token or symbol is plus. Okay, plus is considered recognized as operators. Then the operators, so we can proceed to the second rules. Okay, the second rule mentioned that if the stack is not containing still empty, then we push the stack in the operators into the stack. So we push the plus into the stack. Okay. Okay, next take B. B also recognized as operand, then just print the B, then extend from print right after A. Okay, now the postfix notation is AB. Okay, next take the next symbol is minus. Okay, the next symbol is minus is okay, now we need to compare the operator. In the incoming operator is minus, and the current item, top item in the stack is plus. Okay, now we need to use which rule? Okay, we need to compare in terms of precedent rules, minus and plus. Actually, minus and plus is the same rule in the precedence rule, which is minus and plus located at the same level. Okay, so we can use which one? Equal. If incoming operator has equal, it is the 7 rules. Okay, if the incoming operator has equal precedent with the top of the stack, use associative rules. Okay, associative left to right, then pop and print the top of stack. Okay, what we have to do is if both of the operators incoming and the top operator on the top of the stack is the same level or equal precedent rule, then we need to pop out the operators in the stack. Okay, so pop plus. Okay, this mentioned we applying the 7 rule. Okay, okay, so now there is no item in the stack, so we pop. Okay, pop means remove the item plus. Okay, remove the plus, then we print into the postfix notation. Okay, okay, now the postfix notation become A B plus. Okay, we do not done yet on this token minus. Okay, right after we pop out the plus, then what we still needs to do something on the new incoming token. Okay, next we need to compare again with the stack. Currently there is no item in the stack, so we can proceed to use rules number 2. Okay, because there is no item in the okay, let me write the rules. Okay, this is rule number 7, and push minus, we use rule number 2 because there is no item in the stack. Okay, next we're done with the minus. Now there is one item in the stack, minus. Okay, next C. Okay, take C. Okay, C is the operator operand. Then just print out the operand and expand from the current expression A plus AB plus C. Okay, but we already done with taking out all the symbols in the expression A plus B minus C, but in the stacks we still have one item, which is a minus. Okay, so we need to proceed with rule number 8 that mentioned we need to pop all the item in the stack until empty. Okay, so lastly, pop out the item in the stack, minus, and expand to the Postfix expression. So the final answer is AB plus C minus. Okay, now let's solve this third expression, A plus B multiply C. Okay, first take the first symbol, then the first symbol recognized as operand, and just bring into the Postfix expression. This is mentioned by rule number 1. Okay, next, take the second symbol is plus. Plus is an operator. Okay, so the operator, the stack is still empty, then we can proceed to the rule number 2. We mentioned that we need to push into the stack. Okay, store into the stack. Okay, next, B. The third item is the third symbol is B. B also the operand. The operand print the B beside A, after A. Okay, this is mentioned by rule number 1. Okay, next, multiply. Multiply is an operator. Then delimit the stack already has one item, so we cannot use the rule number 2. Then we need to find rule number 5. Okay, rule number 5 is when incoming operator is higher precedent than the item on the top of the stack. Okay, so in the fifth rule mentioned that we need to push the incoming operator. Okay, push into the stack. So now the current top is multiply. Okay, use the rule number 5. Okay, next symbol is C. C is a operand. Then we need to just print beside the current operand, which is B. So now ABC. Okay, we already done taking out all the symbols from the expression AB plus B, A plus B multiply C. Then, but in the stack still has item which is plus and multiply. Then we need to proceed to rule number 8. Okay, with rule number 8, we need to pop out all the item or operators in the stack until empty. Okay, so we pop out from top. Okay, the top operator is multiply, so ABC multiply. Next is plus. Okay, the final answer is ABC multiply plus. Okay, let's proceed to the fourth expression. Okay, this expression is the most longest expression amount of for expression. Okay, this expression might utilize all the rules in the conversion from Infix to Postfix. Okay, let's do this. Okay, the first symbol is X. Okay, X is recognized as operand. Then just print into the Postfix expression X. Okay, this is rule number 1. The next item is minus. Okay, minus. You can firstly look at the stack. There is none item in the stack. Then we can proceed to rule number 2. Okay, which is push into the stack the operator. Okay, next the incoming symbol is left parenthesis. Okay, left parenthesis. Okay, we can use rule. Okay, there are 2 rules involving the left parenthesis, which is without the stack empty, and another one is stack not empty. So we can proceed to the third rules. Okay, which means this is stated that left parenthesis needs to push into the stack. Okay, now in the stack we have 2 symbol, minus and left parenthesis. Okay, next symbol is Y. Y is the operand. Then just print into the Postfix expression. Okay, become SY. Okay, this is rule number 1. Okay, now multiply. Okay, multiply. Okay, the incoming operator is multiply. Then we need to see in the stack. Okay, in the stack it consists of minus, and on the top of the symbol is left parenthesis. So we can proceed to rule number 2. Okay, the rule number 2 mentioned that the stack is empty or contains left parenthesis, then push. Okay, so we proceed to rule number 2. Okay, we need to push the multiply. So now the item in the stack minus left parenthesis and multiply. Okay, the Postfix expression is still SY. Okay, now left parenthesis. The incoming is left parenthesis. Then we can proceed to rule number 3. Okay. Rule 3 mentioned that if the incoming is left parenthesis, we just push into the stack. Now the item in the stack minus left parenthesis, multiply another one left parenthesis. Okay, next symbol is Z. Okay, Z is the operand. Then we just print. Okay, now before currently SY, then after Z becoming the Z, then just print, then we become SYZ. Okay, next symbol is plus. Okay, plus. Okay, so we need to check items in the stack. Okay, so the top of stack is containing the left parenthesis. Okay, so if we encounter with left parenthesis, then we just push the shift operator into the stack. Okay, this stated in rules number 2. Okay, now the next symbol is D. Okay, the next symbol is D. D is the operand, and just print into the Postfix expression SYZD. Okay, using the rule number 1. Okay, next symbol is multiply. Okay, multiply, we need to check, compare with the current top. Okay, the current top is plus. Okay, which means the multiply is a higher level of precedence. So we can use rule number 5. Okay, push the multiply into the stack. Okay, so now our stack consists of this. Okay, next the incoming symbol is E, is the operand. Operand just bring expand from the current Postfix expression SYZDE. Okay, we'll use rule number 1. Okay, next symbol is right parenthesis. Okay, this is the quite special. Okay, we can use the rules that mentioned about the right parenthesis, which is related one rule here, rules number 4. If the incoming symbol is a right parenthesis, pop the stacks and print operators with left parenthesis found. So means we need to print out all the operators until we found left parenthesis, all the operators until we found the left parenthesis. So now we have two operators before we found the left parenthesis, multiply and plus. So we need to pop two operators. Okay, firstly pop the multiply. Okay, using for the rules. Okay, so it become this. Okay, our stack containing this after remove multiply. Then another one is remove pop plus. Okay, pop plus. Then got only okay, pop plus, then remove plus. Okay, another one pop left parenthesis. Okay, the difference is left parenthesis do not need to print into the our postfix expression. Okay. Okay, so now we have the expression with two additional operators. Okay, next, the next incoming operator symbol is plus. Plus is operator. We compare with the current top. So plus is lower precedence. So we need to use rule number 6. I mentioned we need to pop the operator inside the top of the stack. Okay, pop out the multiply. Then now we have only two symbols, minus and a. Okay. So we can find okay. Then compare with the current top. Okay, the current top is left parenthesis. So if we encounter with left parenthesis, we can proceed with rule number 2 that we mentioned that we need to push operator, the incoming operator. Okay. So now we have 3 items in this stack. Okay, next is C. C symbol is the new incoming symbol. Okay, C is operand, then we just expand from the current expression with the C. Okay, next operand, next symbol is right parenthesis. Okay, again we found with the right parenthesis, then we can proceed the fourth rule. Okay, that mentioned we need to pop the stack until we found left parenthesis. Okay, so this only involve one operators. So pop the plus. Okay, then we got this, then found the left parenthesis and pop the left parenthesis. Then the plus is print at the postfix notation. Okay, next the incoming symbol is division. Okay, division, and then we need to compare the top of a stack. The top of stack consists minus. So same, the division is higher precedent, and we need to push. Okay, that's the fifth rule. Okay. Next symbol is F. F is the operand. Then we just expand from the current expression with the F. Okay. So we already done taking out all the symbol from the expression, but we still have two operators in the stack. Okay. The top operators is divide, division, and next is minus. So we need to pop out all those operators. Okay, using rule number 8. Then we expand to the our postfix notation, the division and minus. So lastly we got this result. Okay, that's why then on the minus. Okay, so hopefully you can do more exercises in order to practice to use these rules. Okay, to select the correct rules in order to depending on the situation, especially with the higher precedent, lower precedent equal, the incoming symbol is the left parenthesis, the incoming symbol is the right parenthesis. And you can try to practice. Okay, hopefully you can understand using to use these rules. Okay. The second conversion is infix to prefix conversion. We can utilize the rules from the postfix conversion infix to postfix. Okay, let me explain the rules of the step to convert from infix to prefix. Firstly, we need to reverse the order of the infix expressions. The original of the infix expression we need to reverse. Okay, secondly, we need to convert the reverse infix into postfix. Okay, we utilize the postfix rules, convert the infix to postfix rules. Then we got the postfix. Then the result of the postfix we need to reverse. Okay. Then finally we got the prefix expression. It seems quite easy because we just use the same rules with the conversion infix to postfix. Okay, so let's do some exercise. Okay, here there are three expressions. Okay, firstly, we try to use the simple one, a plus b. Okay, look at the expression, the step. Firstly, we need to convert, reverse the expression. A plus b become b plus a. Okay, reverse the expression, infix expression. Then after that, the second step, we just impose the rules how to we convert infix to postfix. Okay, as we practiced before. Okay, so convert to postfix. Okay, so we process as the similar way how to convert to postfix. Okay, firstly, take the first symbol or token B. Okay, print result B. Okay, next the next token is plus. Okay, the item is non-item in the stack. So push into the stack. Then another one is get the last symbol is A. A is operand. Then print the operand. Okay, BA. Then we have one item in the stack. Then pop the item from the stack. Finally we get BA plus. Okay, this is the second step. Okay, now after that we need to proceed the other step. Okay, reverse again the postfix to the postfix expression. Then we got the prefix result plus AB. Okay. Okay, the second expression A plus B times C. Okay. Okay, firstly reverse, then become C times B plus A. Okay, next convert to postfix. Okay, we process it using the rules of postfix, convert infix to postfix. Then we got okay, firstly take the first token, the symbol C, print C. The second symbol is operator, push into the stack. Okay, the next symbol is B. B is operand, print into the postfix expression. The next incoming symbol is operator plus. Okay, actually we already have one item multiply. Then compare the level, precision level. Most of the incoming and the top of stack. Then it seems that plus is lower precision. Then we need to use the rules. Okay, use the rule number 6. Okay, basically the incoming is lower precision. Then we need to pop the top of stack. Okay, remove from the stack and print the multiply. Then what we need to do with the plus is we push into the stack. Okay, then the next symbol is A, is a brand, and Fn from the current expression CB times A. We are now done taking all the symbol and expression. Then there is operators in the stack. Then we need to use the rules number 8. It is to pop out all the items from the stack. Okay, plus so another step is we need to reverse again. Okay, the Postfix expression reverse, and finally we got the prefix notation. Okay, the third expression, parenthesis A plus B times C. Okay, firstly, reverse the Infix expression. We got C times right parenthesis B times A left parenthesis. Okay, take the first symbol C, print the C. This next is operator, and still empty. Then we just push into the step. Next is a left parenthesis. Okay. Actually, for the left parenthesis, we assume it from the reverse infix. It state that right parenthesis, but for the use of the rules and converting to postfix, we need to assume the right parenthesis. Means here we assume it as left parenthesis. So we can use the second rule. Okay, push into the stack. Next, symbol is AB is the operand. Then we just append from the postfix expression. Okay, next is the plus is the operator. Then it encounter with the left parenthesis in the stack. Then we can use the second rule also. Just push into the stack the plus operator. Push into the stack. Okay, next A is the operator operand. Then we just append from the expression. Okay, lastly we found the incoming is symbol is right parenthesis. Okay, as I mentioned, we assume it is as a right parenthesis because we want to make with the rules in the postfix expression. Okay, then after we found the right parenthesis, we need to utilize the fourth rule. Means we need to pop out the operators in the stack until we found the left parenthesis. Okay, so inside the parenthesis we have one operator, then pop the operator plus. Okay, right after that we are already done taking out all the operator symbol from the expression. Then we have one item in the stack. Then we proceed to it rule. Okay, push the operators from the stack until empty. Then finally we got CBA plus multiply for the postfix notation. Then we need to proceed the next step, reverse the postfix expression. Then we got the prefix notation. Application that we will share in this video is evaluation of postfix expression. Okay, this is the third operation that we will utilize stack in the operation. So let's look how to evaluate the postfix expression. Okay, there are the rules. Okay, let's see the rules. Okay, there are 4 steps we should consider. There are 4 rules actually. Okay, the evaluation process proceed as follows. Okay, the first rule: when a value is encountered, it is pushed onto the stack. Okay, so to evaluate the postfix expression, we dealing with values, not the variables. Okay, the numeric value. So that's why it's mentioned when a value is encountered, it pushed onto the stack. Okay, this is the opposite how we implement in a conversion Infix to postfix, where the operators push into the stack. But for the evaluation, it's the opposite. They're different. Okay, the value is pushed into the stack. Okay, when a value is encountered, it is pushed onto the stack. Okay, the second rules is when the operators is encountered. Okay, means the incoming symbol is operator. First and second element on the stack are retrieved and popped. Okay, so remove the first and second element or values in the stack. Okay, then the operator is applied. Then it means we calculate using that operator. Okay, both of first and second operand will be calculated with the incoming operators. Note that the second element is the operand. Sorry, not that the second element is the left operand. The first element is the right operand. Okay. Okay, we want to make sure which one is the first and second element. Okay. Okay, the third rule is the result is pushed to the stack. After we calculated with the operator, then the result is pushed back to the operator. The new result. Okay, push back into the stack. Okay, the last rules, when the postfix expression has been processed, the value of the expression is the top, the only left in the stack, element on the stack. So means this rule mentioned that finally we got one value in the stack. Okay, the final value. Then we need to pop the final value for our use. Okay. Okay, now let's do some exercise. There are two postfix expression. We want to evaluate the result of the expression. Okay, firstly x5 4 plus 9 multiply 7 minus. Okay. Okay, then we need to follow the rules. There are four rules actually. There are four rules we need to check. Okay, firstly, okay, the process is quite similar to how we express process or execute in conversion. We copy the expression to the string, then we take one symbol by a symbol. Okay, so we start get from left. Okay, so we get the first symbol is 8. Okay, first symbol is 8 as mentioned in the rules. Okay, the first rule mentioned that when a value is encountered, it's pushed onto the stack. Okay, so the value will be pushed into the stack. Push the operand 8 into the stack. So the item in the stack is 8. Okay, next, get the second symbol is 5. 5 is also the value. So value is operand. Then we need to push. Okay, rule number 1, first rule. So now the stack consists of 8 and 5. Okay, next, also the value number 4. Okay, push the 4 into the stack. Okay, so now it consists of 8, 5, 4. So 4 is the top of the stack. Okay, at the top the stack. Okay, next we receive operator plus in the incoming token. Okay, so what we have to do is when the operator is encountered, first and second element on the top are retrieved and pop. So means we want to remove first and second element on the top. Then after that we apply the operator for using the first and second element. For example, we have operator addition. So get the first and second element means 4 and 5. Okay, then we perform addition operation. Okay, so get the first operand 4 and pop the second operand 5. Then 4 and 5 plus 4 plus 5, then we get 9. So what we need to do with 9 is the third rules. The third rules mention that the result is pushed to the stack. Okay, the result of the operation needs to push into the stack. So push the result 9 to the stack, and we got 8 and 9 in our stack. Okay, next symbol is multiply. Okay, so we encounter with the operators again. Then we need to follow the second rules. When the operator is encountered, first and second is pop. Okay, from the stack. So now we have the value 8 and 9. So get the 9 and first operand is 9 and 8. 8. Second operand is 8. Then we apply using multiply operators 9 times 8. We got 72 values, and the result is Okay, we apply the stat rule, which stated that the result is pushed in the stack. Okay, the result is pushed in the stack, then we have 72 in the stack. Okay, next symbol is 7. Okay, 7 is a value that we need to push into the stack. So the current now we have 72 and 7 in the stack. Okay, next symbol is minus. Okay, minus. So we need to follow the second rule. Means we need to pop second and first and second element and apply the operator using the incoming operator. Okay, 7 and 72. Okay, as we mentioned, that the second element is the left operand. So we need to apply. We need to use a second operand. Okay, 72 as the first element in order to do the operation. Okay, 72 minus 7. So we got 65. Okay, the 65 is pushed into the stack. So in the stack we have the final result. Okay, 65. And just pop the out the element. Then we got the result of the evaluation. Okay. Okay, let's do the second operation. Sorry. Yeah, the second expression is 1 to 6, 1/12 to 6 times 8, 4 divide 7, 5 minus multiply. Okay, let's do this. Okay, firstly take the first symbol is 12. Okay, 12 is the value that we need to push into the stack. Okay, next 6, also the value push into the stack. 12 and 6. Okay, next operator symbol. If we encounter the operator symbol, then we need to pop first and second element. So the first element is 6 and second element is 12. Then apply the both operand with the operators. Okay, so multiply 12 multiply 6. Then we got 72. Okay. Then the result needs to push into the stack. Okay, actually pop the first element. First top element is we remove the 6 and pop the second element will become none. Then the result, okay, we got the new value stored in the stack. Okay, next the incoming value is 8, so push into the stack. 72, 8. So next is also the value number 4, push into the stack. 72, 8, 4. Okay. Next incoming token is division. Okay, so we encounter with the operators, then we need to pop first and second element, then apply on the division operator. Okay, so got the actually we need to apply the second element in the left operand actually. Okay, 8 by 4. Okay, so we got result 2. So firstly the first operand pop out. Second, pop out the second operand, then do the operation division. Okay, divide 4, we got the result in 2. So the result needs to push into the stack. So the current stack consists of 72, 2. Okay, the incoming operator is division. Okay, so we need to push pop to operand. Okay, first operand 2. Okay, the operand is 72. Okay, nothing in the stack. So we need to do the operation division 72 divide 2. Then we got state 36. So 36 is we need to push into the stack. Okay, next operator. Sorry, next symbol is 7. 7 is value, then push into the stack. Okay, so we got 36, 7. Next also the value 5, push into the stack. So we got 36, 7, 5. Okay, next symbol is minus. So we need to proceed the operation, subtraction operation. So pop the first operand is 5 and pop the second operand is 7. Okay, move out to element. Then apply the minus 7 minus 5. Okay, so the second operand is the first operand in the operation. Okay, the subtraction operation. So we got a result into value 2. So push the 2 into the stack. Okay, next we encounter the operator again, the multiply. So pop 2 element on the stack, from the stack. Okay, operand 1, first operand is 2 and second operand is 36, and 36 times 2, then we got 72. Then push the result into the stack. Okay, so this is the final. So there is now incoming symbol from the expression. Then this is the final result. Then we pop result in order to use our usage as a final result. Okay, now I have finished sharing 3 problems using stack. Okay, solving 3 problems using stack, which are converting infix to postfix, infix to prefix, and evaluation of postfix expression. Another thing that you should consider is to check your final result. Okay, for example, after converting infix to postfix, then you can check the result by evaluating the postfix expression and compare with the infix evaluation result. Or you can convert infix to prefix manually without using stack, then compare your result then implementing stack. Okay, so that's all for me. If you have any question, you can place a comment below. So that's all for now. Thank you for your attention.